Good afternoon, Math 8 superstars. So, today's review, it's like we talked about in class today, is function notes. This is an introduction to what functions are. Now, you're probably saying to yourself, Mr. Fischette, what is a function? Well, we've been doing linear functions the whole time. So, in other words, a function can be linear, a function can be quadratic, a function can be in the form of absolute value. But if you think about it, y equals mx plus b, that's a function, right? Because we have x and y. And that's what we're going to talk about here in a minute, how x and y have to do with functions and what a function absolutely is. So a function is a relationship in which each input, or x value, has only one output. And you're probably thinking to yourself, what does that mean? So let's get some vocabulary straight here first. An output is our y value. Okay, so I'm going to put that down. So for every input, there's only one output. So for every x value, there needs to be only one output value to that, or only one value that goes along with that. So I'm going to add some notes to that so you have this, because there's a lot of vocabulary in this. So you got to think to yourself, y value. So I'm going to put y value here. Y values are known as two other things when we're speaking of functions, or just in general. They're also called outputs, or considered to be an output, and they're also considered to be a range. So whenever you hear the word output or range, you should be thinking y value. Okay? So if I move over to this other side, I'm going to put x value. So an x value, like we said in the definition, are two things. An x value can be an input, or it can be what is called a domain, right? They mean the same thing. Those are two terms that are fancy. They're fancy words for x value. So input means x value, and so does domain. So if you ever see that, you got to think x. If you ever see output or range, you need to think y. So, like I said before, a relationship in which each input, or our x value, has only one output. So this is what I want you to think about. I want you to think about going to McDonald's, right? If you go to McDonald's and you order off the value menu, there may be 10 value meals, right? So if I have the same value meal, right? Let's say it's a Big Mac value meal. It's a number one. If I have a number one, right, that is, or that costs several of the same prices, right? If it's the same price, then that's going to be wrong, right? A number one cannot be the same price, okay? So that's what you need to understand going through to this. So, with that being said, you can also think of a machine. Sometimes we do this in math, we call it a function machine. So in a function machine, you put something into the machine and you get something out. So you input something to get something out. You think of the same thing with a computer. If you type into a computer the word dog, the screen will write dog. So your input is the keys, D-O-G, and the output is the word dog. So think of it in terms of machine. If you put something into a machine, a vending machine, you put money in, what do you get out? Hopefully it's something good, right? So input, output means the same thing. We're going to talk more later. We're going to talk about a vertical line test and some other ways to establish whether something is a function or not. But we're going to look at tables first. So we have tables that just have x and y values, right? So our x values here are negative 1, 0, 1, and 2. And then we have 7, 5, 3, and 1. So our table is telling us here that our x values are negative 1, 0, 1, and 2. So we have input values that are all different. And they also have only one unique, or in other words, they have their own output value. So because of that, this is a function. So I'm going to circle this. This is a function. This is absolutely a function. For every x value, it has its only one output value. Now we're going to look at number 2. We have x values negative 1, 0, negative 1, 2. And then our outputs are 7, 5, 3, and 1. So this is what you should be saying to yourself. Whoa, Mr. Fischette, that's not correct. Negative 1 is repeating itself. So that means negative 1 is on here twice, but it has two output values. And they're not the same, they're different. So, for example, if I go back to McDonald's and I order a Big Mac meal, can I pay $7 or $3 for that? No, that's not how it works. So this is not a function. And an easy way of looking at that is the fact that you're looking at your x values. Are they repeating? And do they have different output values or different y values, right? So we are going to look at the next one. This is also not a function, right? Because look, you got input values of all three, and they all have different output values. If I ordered a number 3 on the McDonald's menu, do I have a choice to pay $0, $1, $2, or $3 for that? No way, because I choose $0 every time. So this is not a function because the 3 repeats. So a hint, you want to look at your x values. This is not a function. Now, don't get thrown by the next one. Well, 2 to go. So we're looking at this one. You're like, yep, nope, this is not a function, Mr. Frechette, I got this, right? Because 1 has 2 different values. It doesn't have one unique value. For this to be a function, 1 would have to only be -3. It can't be -3 and 3. Once again, I go back to McDonald's. I'll get the chicken nugget value meal this time. I can't pay for a number 1 -3 or 3. It's got to be 1 and only 1 value. So because of the 1, this is not a function. And I'm going to say NF, not function. So the second to last one. Now, you're probably going to be thrown off by this. We have x values 1 through 4, right? These x values are okay. They each have their own x value. They don't repeat themselves. Therefore, they can have the same output. A number 1 can cost -10, a number 2 can cost -10, a number 3 can cost -10, and so can 4. Same difference. If I went back to McDonald's again and I got a value meal, and I looked at it and it was the same price as a number 2 or a number 3, that is fine. It has its own value. So this is a function. Okay, and we're going to look at the last one. So this is a function. Remember, the secret is to look at your x values. So let's look at the last problem. And you should be saying to yourself that this is also a function because I have -3, -2, -1, and 0. And the y values are all different. And it wouldn't make a difference if they were. We want to look and see that the x values are not repeating. Like, for example, we don't want -3 to be -4 or -3 to be -10 because that wouldn't make sense, right? We're back to McDonald's again. I hate to say it, or Wendy's or wherever. You can't get a taco at Taco Bell for 99 cents or 59 cents. It doesn't work that way. So this is also a function. For every input, there's only one output for that input number. So this is a function. And that is our quick introduction on what a function is. You're going to be working a lot with linear functions, which is basically a line. That's what we've been talking about all along. So everybody have a great night, and we'll be talking more about functions tomorrow. Bye.